Today we are going to study about a topic called orthographic projections. Orthographic projections is a common way of representing 3D objects in 2D space. It is used extensively in all forms of engineering. Orthographic is a combination of two words, ortho meaning straight and graphics means drawing. It is extensively used in engineering and in all domains. You probably have seen many examples of orthographic projections while purchasing a car, a phone, a tablet, or even a house. Or to convert an object from 3D representation to an orthographic representation, we have to utilize three views of the object. We term these views as the front view, side view, and top view. These views of the object are mutually perpendicular to each other. As an example, we are going to be representing this object as an orthographic projection. In an orthographic projection, as mentioned, we utilize three views of the object. The three views are mutually perpendicular to each other. For easy understanding, we have color coded the three views. White represents the front view, green represents the top view, and pink represents the side view. We place the object in this grid, and to visualize the projection, we take an image or a photograph from each of these directions, that is, the front, the side, and the top. We then paste this photograph on the planes behind the object. The resulting arrangement is the orthographic projection. We can open this arrangement to make this projection into a 2D representation of a 3D object. To understand the positioning of these planes, let us recall what we have already studied in past years. Let us consider a simple quadrant system. We have the X and Y lines and four quadrants, 1, 2, 3, and 4. If an object's coordinates can be defined as positive X and positive Y, it is in the first quadrant. If the coordinates are negative X and positive Y values, then it's in the second quadrant. If both the coordinates are negative, then it's in the third quadrant. And if X coordinates are positive and Y coordinates are negative, then it's in the fourth quadrant. Similarly, in 3D space, we can divide the region into four distinct regions. Here, instead of axes, we have planes. We have the horizontal plane, which is a replacement of the x-axis, and a vertical plane, which is a replacement of the y-axis. Like in 2D space, objects can be located in any one of the four quadrants. If the object is above horizontal plane and in front of vertical plane, then it's in the first quadrant. If the object is behind the vertical plane and on top of the horizontal plane, then it's in the second quadrant. If the object is below the horizontal plane and behind the vertical plane, then it's in the third quadrant. And if the object is below the horizontal plane and in front of the vertical plane, then it's considered in the fourth quadrant. It must be noted that the viewer is always looking from the direction as shown in the figure. Like earlier, we will consider that the observer takes a photograph from one of these directions. If the observer is in this position, what he observes is the front view, and in this position he can observe the top view. Like earlier, we are going to consider the top view to be green and the front view to be white. The front view is going to be adhered or attached to the vertical plane, and the top view is going to be attached to the horizontal plane. As we have already seen, there can be 4 possible positions of an object located in space, and depending on its position in space, the positions of the front view and the top view will change. After we have recorded the front view and the top view of the object, what we need to do is to convert this 3D representation into a 2D representation. To do that, we rotate the horizontal plane around the origin in such a manner that it now coincides with the vertical plane. In a 2D representation, the pivot point appears as a line and is denoted by xy. After conversion to 2D, when we view objects which had been placed in different quadrants, we can see that the projections of the objects in quadrants 2 and 4 are not usable, as both the front view and the top view coincide in these quadrants. The objects which had been placed in the first as well as the third quadrant result in usable projection. Objects which had been placed in the first quadrant result in something known as the first angle projection. Objects which had been placed in the third angle result in third angle projection. In first angle projection, we note that the front view is on the top of the xy line, while the top view is below the xy line. In third angle projection, we see that the top view is above the xy line, whereas the front view is below the xy line. In the first angle projection, we see that the object is between the observer and the plane, whereas in the third angle we notice plane is between the object and the observer. We denote the first angle projection using this symbol, while we denote the third angle projection using this symbol. We can obtain these symbols by performing first and third angle projections of a frustum. A frustum is nothing but a truncated cone. In first angle projection, the view of an object as observed from the left side is drawn to the right side, whereas the view observed from the right side is drawn to the left side. In the third angle projection, the view drawn from the left hand side is drawn on the left hand side, whereas the view as seen from the right hand side is drawn on the right hand side. Engineering standards in India dictate that we use the first angle projection. The following are 2 example problems of orthographic projections. The direction you have to consider while viewing the object from the front view is denoted by an arrow. In many of the cases, the side view may not be absolutely required. However, for the sake of completeness, it must be drawn.